Hi class, this is lecture 23 for Econ 4001.02, and I'm your professor, John Rabick. This lecture is going to cover comparative statics of the profit function, and in order to do this, we're also going to talk about the envelope theorem. Hold on, let me just write it like this, envelope theorem. So the envelope theorem is one thing that, oh, where did it go? The envelope theorem is one aspect of optimization that we haven't really talked about yet. And this is one that allows you to get comparative statics of things in a very nice way. So we'll define the envelope theorem and show how to use it to get comparative statics of the profit function. Great, so comparative statics of profit. We're often interested in how profit changes with a change in prices, right? So this could be output prices or input prices. And the results are going to be surprisingly simple. And the reason they're going to be simple is that they just follow from the envelope theorem. And this will actually tell you some important information. So I'll discuss what this means from the perspective of a researcher in a second. So first, let's talk about the envelope theorem setup. So suppose you have a maximization problem where you're maximizing this function g with respect to x, where g depends on alpha, and you have a constraint h that depends on x, or that you're optimizing with respect to x that depends on beta. First, you can just write the maximum of this optimization problem, in fact, as a function. And this function has a special name, and this is the value function, and this is the value of the maximum, and this then is a function that depends on parameters alpha and beta, but it does not depend on x. We're also going to suppose that the optimal solutions to this maximization problem then are given by this x star that depend on alpha and beta. And again, here we're just dealing with two variables. And we're going to suppose all of the above functions are differentiable, just for simplicity. There are actually envelope theorems that hold under very weak conditions, but this differentiability condition is a very nice one to deal with. So recall that the Lagrangian of in order to get an idea of how this envelope theorem works, recall that the Lagrangian of a general problem is given by L that depends on x and lambda. And it's going to turn out, actually, that the derivative of our value function with respect to alpha just depends on this direct effect. And the derivative of our value function with respect to beta is also just going to depend on the direct effect. So anything that happens from the change in lambda or other changes of x's and the solution function won't enter into the change of the value function, right? So this is something that I really just want you to remember, that if you have these changes and you're looking for changes in these value functions with respect to some parameter, that you can just look at the direct changes either immediately evaluated at the optimal solution, or the direct change scaled by the Lagrange multiplier, right? So these are the two ways that these kinds of comparative statics will show up when things are differentiable. Great, so this is kind of abstract, so it's going to be a little bit easier to apply it to a specific problem. Oh, and in words, this is just the comparative static of the value functions only depend on direct effects from the functions we're in fact looking at and the parameters that they depend on. So we're going to apply this to the profit function. So here we can define the profit function as the profit you make at output price P and input prices given by W. This is a value function, so we can look at comparative statics with the envelope theorem. But looking at the comparative statics using the envelope theorem, if we differentiate profit with respect to price, we're just recovering the derivative of this direct component, right? The only thing that depends on price is this, and the derivative of this with respect to price is just our output. So in fact, the change in profit with the change in price is just equal to our output. And we can do the same thing for the input prices, right? And if we do that, we'll find that the change in profit with respect to the input price is just exactly equal to our input. Now, why do we care about this? Well, from a research perspective, the profit is something that's easy to observe, right? Companies need to report their profits, either to the government or some tax agency, but they don't need to report information on their production processes or how much inputs they use oftentimes, right? So, companies don't need to report this or this or this. But also, we might be able to observe things that we think are related to prices, right? I can see how much limestone costs. I can see how much electricity costs. I can see how much cement is selling for. So this means we can actually look at oftentimes comparative statics of profit from data here. But if we know someone is profit maximizing, then we can recover this information, right? So this gives us information about the production technology. And here, if we look at the derivative of profit with respect to input prices, this gives us information about the inputs they used and how much they actually demanded. So this is useful because, if you assume someone is maximizing something, then it says you only need to observe this maximized object in order to recover information about these other things that the firm chose or has in the background. So that's why this is a pretty cool theorem and why the envelope theorem in general is just so important. Great, so this lecture we discussed the envelope theorem and we discussed how to apply this to profit functions in order to look at comparative statics. Great, thank you so much for listening and I'll see you next time.